Hello, I'm Ciura Weimershaus. I'm a researcher working in neuromuscular disorders.
Hello, my name is Ciura Weimershaus and I'm a researcher in neuroimmunology. Today, the 21st of June, is the Global ALS Awareness Day. This date hasn't been chosen without reason. Summer solstice, this date symbolizes for the families and the patients concerned by ALS, turning point in the treatment of ALS. At the occasion of the Global ALS Day, we would like to raise awareness and keep you updated on our latest research.
ALS, amyotrophic lateral sclerosis, or Charcot's disease as it is known in France. It's a devastating neurodegenerative disorder that leads to paralysis. Currently, there are over 500,000 people living with ALS around the world, and around 6,000 only in France. ALS is devastating for patients, for their caregivers, for the families, and for the society at large. Today, there are no treatments that can cure or drastically slow down the disease. In ALS, the motor neurons, which are the neurons that innervate our muscles and help us move, are the ones that specifically degenerate, leading to paralysis. As researchers, we are investigating the mechanisms through which these motor neurons are degenerating, and we are trying to find molecules and drugs that can block this degeneration. Currently, one of the drugs that we are studying is
Masitinib. Masitinib has been co-developed in the lab of Olivier Armin in Imagine Institute and is a molecule that can block the activation of certain immune cells. Why is the role of immune cells important in ALS? Although we would rather think that the immune system protects our body, there are actually conditions where the immune system is too activated or in an inappropriate way, and this leads to damage on cells and tissues. And this seems to be the case in ALS. Using Masitinib, we try to block this aberrant activation of immune cells to protect the motor neurons, which are vulnerable in this disease. Masitinib has even been tested on ALS patients, where it shows positive effects. It improves cognition and motor functions and has even prolonged survival. This is a very important step in the development of Masitinib and to bring it on the market as a treatment for ALS.
Further studying the action of Masitinib in the lab will fulfill two aims. One is to understand better molecular mechanisms of motor neuron degeneration using this effective drug. The other one is to improve on this treatment and on its administration. One way to study the actions of Masitinib is to use cellular models, such as the cells obtained from patients that we transform into motor neurons. Since Masitinib has an action on immune cells, we combine these motor neurons with a specialized type of immune cell called the mast cell. And we're trying to understand what are the communicating signals between motor neurons and mast cells, and how does Masitinib exactly act to protect motor neurons from this degenerating signal.
Next to the cellular models, we also use model organisms, because cellular models are very potent, but they have a number of limitations. Just because we can treat cells with a molecule and obtain the desired effect doesn't mean this will also work in a complex organism, in the full body actually. In the lab, we use the zebrafish to model the disease. Swimming in the fish is a motor neuron action. So the ALS fish is unable to swim correctly. It is basically paralyzed. When the treatment works, the fish will be able to swim again. And this is exactly what we observe in the case of Masitinib. This leaves us with a great tool to study precisely the cellular and molecular mechanisms of Masitinib and to understand better the disease. Today, research is our best hope to find a cure for ALS. Thank you for listening.
Raising awareness about ALS is important for supporting the patients, supporting research and drug discovery, so that we can finally cure this devastating disorder. Thank you very much for your attention.